Hello, everybody. My name is Dr. Chris Moore, and I'm a research associate at West Virginia University in the Industrial and Management Systems Engineering Department. And I'm also the project manager of our WVU pollution prevention team. And today I'm going to be presenting on the topic of pollution prevention best practices for the for the automotive manufacturing and maintenance industries. So in this session, the focus will explore many pollution prevention best practices that can be implemented within these industries that can decrease environmental impact and improve or maintain profitability. So more specifically, in this webinar, I'll first provide a brief introduction into pollution prevention as defined by the Environmental Protection Agency and what activities are and aren't considered pollution prevention. Next, I'll discuss EPA's national emphasis areas, which are prioritized industries under EPA's pollution prevention initiative. The main focus of this webinar, however, will be the third national emphasis area, automotive manufacturing and maintenance. So I'll provide some background into the industry, then cover several pollution prevention best practices that can be implemented by facilities within those industries to minimize their environmental impact and cut pollution at the source. Then after a brief summary, I'll do my best to answer any questions you may have. If you have any questions along the way, feel free to post them into the chat, and I'll be happy to address them after the presentation. So before diving into the topic of pollution prevention, we first need to understand pollution. So pollution, according to the Oxford Dictionary, is the introduction into the environment of a substance or thing that has harmful or poisonous effects. So pollution has far-reaching consequences, not only affecting human health, but also disrupting ecosystems and threatening biodiversity. Given these impacts, it's clear that immediate action is needed to reduce pollution and its adverse effects. Now, pollution prevention, as defined by the U.S. Environmental Protection Agency, refers to any practice that reduces, eliminates, or prevents pollution at its source before it's created. This approach differs from pollution control, which typically deals with managing pollution after it has been generated. Instead, P2 focuses on proactive steps to prevent waste and pollution from occurring in the first place. So this hierarchy of pollution management shows a step-by-step approach to managing pollution, starting with the most desirable actions at the top and moving to the least preferred options at the bottom. So when possible, the creation of pollution should be prevented in the first place. So if the creation of a pollutant can't be completely prevented, then the next objective should be to reduce the amount that is created. So when you can't reduce the amount of a pollutant, the next option would be to reuse or recycle, and those options should be explored. The next step, recover, refers to the process of extracting any useful material or energy from the waste. And the least preferred option is disposal, where the waste will go to a landfill or otherwise be released out into the environment. EPA's Pollution Prevention Initiative emphasizes this hierarchy, encouraging a primary goal of preventing and reducing pollution at the source. As part of the EPA's Pollution Prevention Initiative in 2015, several priority sectors known as national emphasis areas were identified. These 6 sectors were identified as priorities by the EPA program to focus resources and efforts for maximum environmental and economic impact. These sectors offer substantial P2 opportunities and create a focused approach that allows for better resource allocation and the ability to share successful strategies across similar industries. The original 5 NEAs were food and beverage manufacturing and processing, chemical manufacturing, processing and formulation, automotive manufacturing and maintenance, aerospace product and parts manufacturing and maintenance, and metal manufacturing and fabrication. A 6th national emphasis area was established several years ago, but instead of focusing on a specific industry sector, the EPA realized the need for assistance with pollution prevention on tribal and native lands within the country. So today's focus will be on NEA number 3, the automotive manufacturing and maintenance industries. You can find our webinar on NEAs 1 and 2 on our YouTube channel or on our website. And in the coming months, we'll be hosting webinars that cover the remaining 2 industry-related NEAs. So keep an eye out for more information on those. So the automotive manufacturing and maintenance sectors includes automotive manufacturing industries classified under the NAICS codes beginning with 3361, 3362, and 3363, and also the automotive maintenance industries classified under codes beginning with 8111. So in 2020, there were over 7,200 establishments within this sector, with 823, or about 11% of them, reporting to the toxic release inventory. So the chart ahead shows the volume of waste managed by different approaches from 2011 to 2020 in this industry. So since 2011, additional waste has been managed by being recycled. And overall waste decreased from 2018 to 2020, which is promising. However, there hasn't been much change in the amount of waste that is treated or disposed, and that leaves opportunities for implementation of pollution prevention and source reduction best practices. So overall, the industries in this sector can be grouped into 4 different specialties, namely motor vehicle manufacturing, motor vehicle body and trailer manufacturing, motor vehicle parts manufacturing, and automotive repair and maintenance. So now that we've discussed the types of industries in the automotive manufacturing and maintenance sector, we'll spend the remainder of the session covering 9 P2 best practices that are applicable to businesses within these industry sectors. The best practices that we will be discussing can be broadly classified into 3 categories. First, we will talk about a few best practices related to management of waste fluids. Next, we'll discuss several alternatives and substitutes to commonly used products within these industries. And finally, we'll discuss a couple of other P2 practices that don't quite fit within the other 2 categories. So first, used fluids are very common in this sector. Motor oil, transmission fluids, coolants, brake fluid, among others. And these fluids, if not managed properly, can be dangerous to the environment, wildlife, and to human health. So let's start by looking at a few best practices related to fluid management and recycling, including implementing an ultrafiltration process for recycling fluids in parts washers, using recycled content and extended life antifreeze, and using filtration along with regular spiking to extend acid baffling. So the first best practice we'll cover is implementing an ultrafiltration process for recycling fluids in multi-stage parts washers. So parts washing is a routine task in the automotive manufacturing and maintenance sector. In the automotive manufacturing industries, the parts often need to be washed after production to remove any oils, debris from machining, and other contaminants before they can be packaged and sold. And in the automotive maintenance industry, parts that are removed from vehicles during maintenance or repair may need to be cleaned before reassembly to remove dirt, grease, oil, and other contaminants. Parts washing fluid, which is used in parts washing baths and can be water-based or solvent-based, becomes contaminated during the parts washing process and must be disposed of properly and replaced. So as I mentioned, parts washing fluid comes in 2 types, solvent-based and water-based. Solvent-based parts washing fluids are generally more effective at removing grease and oils than water-based solutions, but water-based solutions have improved significantly with time. Regardless of the type of fluid, it must be managed and disposed of properly. The contaminated fluid must be treated as hazardous waste and must be stored until it is ultimately disposed, and the disposal costs can be significant. If released without proper treatment, the waste fluid can cause substantial harm to the environment. While both types of parts washing fluid generate waste, the waste from solvent-based parts washing fluid is generally more challenging to manage. Water-based parts washing fluid is cheaper as it can be purchased in smaller quantities and diluted with water to fill the parts washer. Depending on the size of the parts washer, though, frequent changes of the fluid can result in significant consumption of water, and that water will likely need to be treated as hazardous waste. Solvents-based parts washing fluid is more expensive and must be purchased in larger quantities since it's not meant to be diluted with water. Solvent-based parts washing fluid is more dangerous, though, to the workers than water-based fluids. But either way, there are going to be substantial costs involved. So one possible solution is to filter and reuse the fluid instead of just disposing when it becomes too contaminated. Ultrafiltration technology can be used to remove contamination from the washing fluid, allowing the fluid to be reused. During the ultrafiltration process, the waste, in this case, the used parts washing fluid, is sent through a membrane under low pressure. The membrane filters out all but the smallest molecules, ensuring that most or all of the contaminants are removed from the used washing fluid, allowing the fluid to continue to be used. This technology was originally designed for the food industry, but advances in filtration technology and the development of stronger membranes made it appropriate for use with parts washing fluid. These stronger membranes, such as polyvinylidene difluoride, can handle industrial process solutions with high pH levels, elevated temperatures, and high oil concentrations. Ultrafiltration is regarded as a top technology for extending the longevity of various process solutions due to its unique capability to concentrate oily waste and produce clean permanent. So the use of ultrafiltration to extend the life of parts washing fluids comes with several benefits. By extending the life of the parts washing fluid, the amount of parts washing fluid used and waste generated is reduced significantly, which has environmental benefits. Additionally, the waste generated from the removed contaminants is condensed, allowing for easier storage and disposal. When water-based parts washing fluid is used, extending the life of the fluid will also conserve fresh water. Additionally, if a continuous closed-loop filtration system can be implemented, the fluid in the bath can remain fresher. This, along with the reduced need for fluid changes, can improve operational efficiency. The benefits from implementation of an ultrafiltration system can result in significant cost savings from reduced need for parts washer fluid, reduced labor, and reduced disposal costs. Moving on, the next recommendation is to use recycled content and extended life antifreeze. Antifreeze is a critical fluid in vehicles. The antifreeze circulates through the engine, removing heat from the engine and keeping it from overheating. The primary ingredient in antifreeze is propylene glycol or ethylene glycol. Unlike water, which freezes at 32 degrees Fahrenheit, antifreeze is designed to stay a liquid as low as negative 34 Fahrenheit, ensuring it does not freeze during the winter months. A typical passenger vehicle will require several gallons of coolant or antifreeze, with larger vehicles having capacities over 10 gallons. However, improper use or disposal of antifreeze can lead to several significant problems. First, antifreeze contains toxic chemicals that, if improperly disposed of, can contaminate soil and water, harming ecosystems and damaging the environment. Antifreeze is also flammable, and the vapors can accumulate and easily ignite, so improper handling or disposal can pose significant risk to the employee's property and ongoing operations. In addition, mixing antifreeze with other fluids or improper handling can result in contamination, which can make disposal more complex and expensive. Also, mishandling antifreeze can result in violations of environmental and safety regulations, leading to fines and legal consequences. So while it doesn't eliminate all the risks, many of them can be reduced by using antifreeze that is made from recycled content and or designed to be extended life. So let's talk briefly about each of these. So recycled content antifreeze is antifreeze that, as the name suggests, is produced from antifreeze that has been used and that had the contaminants removed. The inherent properties of antifreeze allow it to be recycled an unlimited number of times, and through advanced chemical filtration and reconditioning processes, used antifreeze can be restored to meet or exceed industry standards. There are several ways that antifreeze can be recycled, some of which could be implemented in-house to reduce costs or generate additional profit. Extended life antifreeze, on the other hand, incorporates advanced chemical formulations designed to last significantly longer than conventional antifreeze. This reduces the frequency of replacements, conserving resources and lowering costs. So there are also antifreeze options that have both characteristics. They're made from recycled propylene glycol or ethylene glycol, and they have additives to extend their life. So some of the benefits of using recycled content and extended life antifreeze. First, using these products helps protect the environment, as they do not require creation of more ethylene or propylene glycol that would be required for new unrecycled antifreeze. Ultimately, antifreeze that cannot be recycled will be sent to a landfill for hazardous waste, which will always pose an environmental risk. By using recycled content antifreeze, the amount of antifreeze disposed after use reduces significantly and reduces the waste that ends up polluting the environment, while also conserving valuable resources like water and chemicals. And since extended life antifreeze is formulated to last longer, reducing the frequency that antifreeze needs to be replaced can save money on maintenance costs. So next, acid baths. Acid baths play a crucial role, especially in the automotive manufacturing industries. They have a variety of uses. So acid baths are used to remove rust from metal parts and prepare surfaces for further processing, such as welding or coating. And acid baths with certain acids, like nitric acid, can be used to increase corrosion resistance of stainless steel parts in a process called passivation. So in a moment, we'll look at a couple of techniques that can be used to extend the life of acid baths. But first, let's discuss some of the risks associated with acid baths. Acid baths are comprised of harsh acidic chemicals. Improper disposal of used chemicals can result in environmental contamination, entering soil and water and causing harm to the ecosystem. There are also safety hazards associated with the handling of these acids, including chemical burns, spills, and exposure to toxic fumes. These incidents are most likely to occur when changing the acid bath, and if an incident does occur, it could affect operations and delay or stop production. Additionally, OSHA has regulations that directly or indirectly govern the use of acid baths, so improper storage, handling, and use of these chemicals could result in penalties and fines. And finally, frequent replacement of acid baths can increase downtime of a process and will use significant amounts of these acids. Together, risks associated with acid baths can significantly increase operating costs and ultimately affect profitability. So one possible solution, instead of changing the acid baths when they're contaminated, the acid baths can be filtered and spiked with fresh acid. Filtration of the acid bath removes any solid contaminants that have accumulated, while adding additional acid to the bath will maintain its effectiveness. These methods together can significantly extend the life of the acid bath, in some cases making it viable almost indefinitely. So let's look at some of the benefits of filtering and spiking acid baths instead of frequent changing. First, this type of recycling of the acid bath can lead to a significantly lower volume of acid waste, which is beneficial to the environment. Next, there will be resource savings. Filtering removes contaminants, allowing acid baths to be reused for longer periods, while spiking replenishes the chemical balance. This minimizes the need for fresh acid and reduces overall resource consumption. Also, extending the lifespan of acid baths lowers the cost of purchasing fresh acids and disposing of spent solutions, providing significant financial benefits. Finally, regular filtration and spiking can help with regulatory compliance. Properly managing acid baths helps meet environmental and safety standards while avoiding fines and legal penalties. So in a case study at an anodizing facility, it showed the effectiveness of the above-mentioned technique in extending the life of sulfuric acid baths. It was found that the facility was frequently sending used acid baths to the wastewater pretreatment facility. Before the application of acid life extending techniques, they were changing their acid bath partially on a regular basis, and every 6 months they were completely changing their acid baths. And annually, the company was spending about $3,000 to replace the spent sulfuric acid baths. But with these techniques, they were able to reduce that number to about $1,000 per year. So the $1,600 investment into these methods resulted in a savings of over $2,000 per year, meaning the implementation paid for itself within the first year and the company's costs were reduced significantly. This also represented more than a 50% reduction in sulfuric acid waste being disposed of each year. Now, in the next section, we'll discuss a few practices related to eco-friendly alternatives and substitutes. That'll include things like switching to non-lead wheel weights, switching from products based on glycol ethers, switching from sulfuric acid-based wheel cleaner to a non-corrosive cleaner, and switching from solvent-based parts cleaners to aqueous-based, water-based parts cleaners. So in the automotive repair and maintenance industry, wheel weights are affixed to the inner lips of a vehicle rim, of vehicle rims to balance the wheels. And if you don't do this, that can lead to vibration in the car that can be felt when driving. So traditionally, these wheel weights were made of lead due to the density, the malleability, and the low cost of lead. However, lead is highly toxic, with continued exposure increasing the risk of many conditions, including neurological problems, kidney damage, gastrointestinal issues, reproductive issues, among others. It's not unusual for wheel weights to fall off of vehicles and end up in the environment. When the lead enters soil and water systems, it contaminates the environment, harming plants, animals, and aquatic life. A related issue to this is bioaccumulation. Lead persists in the environment and accumulates in the food chain, impacting wildlife and eventually reaching humans through contaminated water or food. This can lead to long-term health risks. In addition, during their manufacturing, handling, and installation, workers may be exposed to toxic lead dust or fumes if proper precautions are not taken, increasing the risk of lead poisoning, causing worker safety issues. And finally, the use of lead wheel weights can result in regulatory non-compliance. Many regions have banned or restricted the use of lead in products due to its environmental and health hazards. So instead of using lead wheel weights, several other options exist that do not involve the same risks. There are multiple substitutes to lead wheel weights, all of which are safe and non-toxic, including steel wheel weights, zinc weights, plastic-coated wheel weights, and composite or alloy wheel weights. So the steel is going to be the cheapest alternative to lead wheel weights, but steel will corrode. Zinc, on the other hand, is more corrosion resistant and more environmentally friendly than steel, but it's slightly more expensive. Plastic coated wheel weights are more expensive than steel or zinc, but they are more environmentally friendly because they are made from recycled materials. They will also be more corrosion resistant due to the plastic coating. Composite and alloy wheel weights are another option, but due to the more advanced materials, they tend to be the most expensive alternative. So when considering cost and safety, zinc wheel weights or plastic coated wheel weights are the best options. So some of the benefits of using non-lead wheel weights. So as mentioned earlier, alternatives like steel and zinc are non-toxic, eliminating the risk of lead contamination in soil and water, improving environmental safety. In areas that have regulations against the use of lead wheel weights, using non-toxic alternatives can help maintain regulatory compliance. Furthermore, worker safety is enhanced since alternatives do not release harmful lead dust or fumes during handling and installation. The risk of lead poisoning is reduced, creating a safer workplace for employees. And also, since non-toxic wheel weights are safer to store and handle, less precautionary measures are required, making inventory management easier. So next, let's talk about products based on glycol ethers. So glycol ethers are chemical compounds consisting of alkyl ethers based on glycol, such as propylene glycol or ethylene glycol. They act as solvents and are commonly found in the automotive manufacturing and maintenance industries in cleaners, degreasers, aerosol paints, water-based paints, and adhesives. However, some of these glycol ethers are highly toxic and can pose serious risks to both human health and the environment. There are also risks of acute short-term exposure and chronic prolonged exposure to human health. Low-level short-term exposure can cause skin and eye irritation, where higher-level exposures can lead to narcosis, pulmonary edema, and severe liver and kidney damage. Prolonged exposure to glycol ethers can lead to neurological and blood effects, including nausea, fatigue, tremors, and anemia. So without proper handling procedures, risk of glycol ether exposure is increased and worker health is at risk. Beyond the health risks, improper disposal of glycol ether-based products can harm ecosystems and can lead to regulatory non-compliance, resulting in fines and penalties. So these risks can be mitigated by reducing or completely eliminating the use of glycol ether-based products in industrial processes. There are several options available to reduce or eliminate the use depending on the application. So when glycol ethers are used for their solvent properties, aqueous-based solvents may be a viable alternative. Aqueous-based solvents use water as a base instead of a toxic chemical and therefore are safer and more environmentally friendly. Another effective approach may be to implement process changes, modifying operations to minimize contaminant formation, or using methods that clean surfaces without solvents can reduce the reliance on hazardous chemicals. These changes not only lower the use of glycol ethers, but also reduce the frequency of cleaning required. A closed-loop cleaning system is also a valuable solution. These systems recycle and reuse cleaning solvents, drastically limiting the amount of glycol ethers that are used and ultimately disposed. This approach reduces pollution, conserves resources, and cuts down operational costs. Another option when the above solutions are not viable is to consider mechanical cleaning of parts. So there are methods like dry ice blasting that can be more eco-friendly than solvent-based cleaning approaches. And ultimately, if glycol ethers must still be used, proper ventilation should be ensured for the safety of employees. So there are several benefits to switching from glycol ethers to safer alternatives. First, the practices we just discussed are more eco-friendly. So by replacing either glycol ethers with safer alternatives or reducing their use, reducing the use and subsequent discharge of toxic substances helps protect ecosystems and prevent pollution. Next, these alternatives minimize worker health risks. So without exposure to harmful glycol ethers, workers are less likely to suffer from short-term effects like nausea and irritation or long-term conditions such as kidney and lung problems. Additionally, transitioning to safer alternatives eases regulatory compliance. By avoiding hazardous chemicals, industries can meet environmental and safety regulations more effectively, avoiding fines and maintaining a positive reputation. And finally, the use of alternatives often involves products that are easier to handle and manage. This simplifies processes and improves efficiency in the workplace, reducing the need for complex storage or disposal systems. So next, wheel cleaners are commonly used in these industries to remove brake dust and other contamination from the rims of vehicles. Brake dust and other metal-based contamination does not easily wash off with soap and water. So acid-based wheel cleaners work well because they can dissolve the metal-based contamination. And one of the most common ingredients in acid-based wheel cleaners is sulfuric acid. So with these being acid-based, though, they have their risks. So sulfuric acid is highly corrosive. And like I mentioned, that's why it works so well to remove metal-based contamination. However, if not used properly, it can damage vehicle surfaces, tools, and equipment, especially over time. And this can lead to costly repairs and replacements. And for workers, accidental contact with this chemical poses health risks, including burns and irritation. Next, acid-based wheel cleaners generate hazardous waste. Those wheel cleaners are often sprayed onto the surface, allowed to dwell for a period, agitated with a brush, then rinsed off. In some areas, this rinse water must be captured and disposed of properly. When released into the environment, the waste can affect ecosystems and can pollute water sources. Additionally, these cleaners require careful handling. Strict safety measures are necessary to prevent accidents, which increases operational complexity and cost for business. Lastly, improper use of sulfuric acid-based cleaners can result in regulatory compliance issues. Many regions have stringent environmental and safety laws that limit the use of these chemicals, and non-compliance can lead to penalties, fines, and reputational damage for the business. So here are a couple possible options as alternatives to acidic wheel cleaners. Water-based cleaners are an excellent replacement as they are non-corrosive, safer for workers, and they're environmentally friendly. And while they're not quite as effective as acid-based wheel cleaners, advances in formulations of these products has made them effective enough to be viable options. They can effectively remove dirt, grime, and brake dust without the risks of acid-based wheel cleaners. Sorry. They're environmentally friendly, they're safer, and they do not require special handling. Another option would be dry ice blasting. This technique, which is similar to sandblasting, uses compressed air with dry ice pellets as the abrasive media to clean surfaces without any chemical residues. It's highly effective in removing contaminants while being completely safe for the environment and workers. Plus, it eliminates the need for water or detergents, reducing waste and simplifying cleanup. So switching from acid-based wheel cleaners brings several key benefits. First, the workers will be safer. Eliminating the use of acid-based products removes the risk of exposure on the workers, reducing the risk of chemical burns and harmful fumes in the workplace. Next, non-acidic cleaners make regulatory compliance easier. Products that are environmentally friendly and don't contain toxic substances are one less thing to worry about when it comes to compliance. Another benefit is that these methods have no corrosive effects on parts. Unlike acid-based solutions that can degrade metal surfaces and components over time, water-based wheel cleaners and dry ice options don't carry these same risks. And lastly, they contribute to environmental safety. Non-acidic and water-based wheel cleaners, as well as methods like dry ice blasting, minimize pollution and hazardous waste, reducing the environmental footprint of operations. So next, solvent-based cleaners are generally appreciated in this industry for their ability to effectively dissolve oils and grease. However, like we've kind of mentioned with other solvents, they pose a lot of risks. One of the primary concerns is the toxicity and health hazards. These cleaners often contain harmful compounds such as trichloroethane, trichloroethylene, benzene, and xylene substances that are either toxic, carcinogenic, or both. Prolonged exposure to these chemicals can lead to severe health risks for workers, including respiratory issues, skin irritation, and long-term illnesses. Next is flammability. Solvent-based cleaners are highly flammable, posing significant fire risks in the workplace. This creates a hazardous environment, particularly in high temperature or poorly ventilated areas. Solvent-based cleaners also have environmental concerns. During use, they release volatile organic compounds, contributing to air pollution and impacting surrounding ecosystems. And as environmental regulations tighten, solvent-based cleaners face regulatory challenges, making compliance increasingly difficult. The solution then is to switch to water-based, aqueous-based cleaners. Instead of solvents, these cleaners use water as the primary solvent and combine with detergents, surfactants, or other additives to improve their cleaning power. This makes them highly effective at cleaning while avoiding the risks associated with traditional solvent-based cleaners. Aqueous-based cleaners are also non-toxic and non-flammable. They do not release volatile organic compounds during use, and disposal is easier. These aqueous cleaners have several benefits over solvent-based cleaners. First, worker safety is enhanced since the aqueous cleaners are safer for human health. In addition, with no VOCs and a non-hazardous classification, their environmentally friendly composition means it's easier to meet environmental and safety standards, and there will be less pollution. And furthermore, they have lower disposal costs. Unlike solvent-based cleaners, aqueous solutions are easier and less expensive to manage as they don't generate hazardous waste, cutting down on disposal expenses. Now, finally, we'll talk about a couple other P2 practices in this field or in these sectors that don't quite fit in with the other two categories. And those will be the use of cotton cloths for standard cleaning procedures and insulating equipment. So first, we'll look into the use of reusable cotton cloths as an alternative to disposable shop towels or other single-use wipes in these industries. Disposable shop towels are often used in these industries to clean dirt, grime, and grease from parts or workers' hands, or to wipe or soak up automotive fluids. There are also many products in the automotive sector, including cleaning products, degreasers, protectants, and other car care products that come as packs or containers of single-use wipes. The use of these single-use products in the automobile manufacturing and maintenance industries poses several challenges. First, they lead to high waste generation, contributing significantly to landfill accumulation and environmental pollution. And when disposable shop towels are saturated with hazardous wastes like grease, oil, solvents, and so forth, they should be treated as hazardous waste and disposed of appropriately, not just tossed into a garbage can. This makes proper disposal expensive and exposes you to risk of fines or other penalties for improper disposal. So cotton cloths are a possible alternative to both disposable shop towels and products that come as single-use wipes. So for disposable shop towels, they can be a direct replacement. So these can be used to for the same purposes as the shop towels, wiping off hands, cleaning up parts, so forth. Products that come as single-use wipes are usually available in different formats. They can come in spray bottles, bulk containers of a gallon or more, or concentrated solutions that must be diluted down with water. These product formats can be applied or wiped off with a cotton cloth. These other formats are also more economical than the single-use wipe products. So instead of using these single-use wipes, we can buy these products in other formats and use them with these cotton cloths that are reusable. So cotton cloths have many benefits over disposable towels and single-use wipes. They'll reduce waste since they're reusable. If they're used with non-toxic products or to clean up non-toxic dirt and contamination, they can be rinsed, machine washed, and reused. When used with hazardous materials, however, they will need to be treated as hazardous waste. They're also more durable. Disposable shop towels and single-use wipes are thin paper sheets and may tear or shred when used along sharp edges or on rough or abrasive surfaces. Cotton cloths are much more resistant to that type of shredding and tearing. They're also more effective since they're more durable. They also tend to be better at cleaning than their disposable counterparts. And finally, cotton cloths enable cost savings by eliminating the need for frequent purchases of disposable wipes, making them a practical and economical choice for cleaning operations in the automobile industry. And finally, the last pollution prevention best practice that we will discuss before we wrap up is going to be about insulating equipment. So in equipment that needs to be kept hot, like furnaces, boilers, steam systems, and ovens, where the heat is necessary for the process, and for equipment that needs to be kept cold, like, for example, freezers, chillers, and coolers, poor insulation can be extremely costly. Equipment that heats and cools can be very energy intensive, especially when it comes to maintaining extremely high temperatures. If the heat escapes one of these hot processes or infiltrates a cold process, energy is wasted. So heat loss is typically due to poor insulation of equipment and will impact both efficiency and sustainability. This wasted energy comes at a significant cost. When heat is lost from a process, it needs to be replenished, meaning additional energy costs. Additionally, escaped heat from processes and equipment could necessitate the need for additional HVAC usage to counteract that additional heat that's being released into the environment, and that can further increase energy costs. Another concern is the larger carbon footprint. So higher energy use directly translates into increased greenhouse gas emissions, negatively affecting the environment. And additionally, heat loss can affect process control. So if heat is lost from a system that requires precise temperature controls, the process becomes harder to control, which can affect process speed and could ultimately affect product quality. And finally, uninsulated surfaces in hot processes are a hazard to the workers as they create a burn risk if people come in contact with them. So the solution here is to just insulate the equipment to try to keep the heat from transferring. So insulation is an inexpensive solution to this problem. Insulation is designed to minimize the amount of heat transfer through a surface. By insulating exposed surfaces, heat loss can be minimized. So insulation is rated with an R value, which indicates its resistance to heat transfer. A higher R value indicates better insulating ability. There are two primary types of insulation that are used to insulate equipment in industrial processes. That'll be fiberglass insulation and mineral wool insulation. So the fiberglass insulation has a lower cost, but each inch of fiberglass insulation only increases the R value by about 3 for each inch of thickness. Mineral wool insulation, which is also known as rock wool, is a higher cost alternative to fiberglass insulation, but it has some other benefits. First of all, mineral wool has a higher R value. With each inch of rock wool, mineral wool insulation thickness, increasing the R value by about 4. Mineral wool insulation is believed to be safer to human health and the environment than fiberglass insulation. And mineral wool insulation can withstand higher temperatures than fiberglass insulation. So proper insulation of surfaces to minimize unintended heat loss in high temperature processes comes with several benefits. First and foremost, energy savings. Avoided heat loss translates directly into energy savings, reduced operational costs, and reduced environmental footprint. Additionally, proper insulation can minimize thermal strain on equipment, extending its lifespan. This all leads to a more sustainable business. So as an example of the potential cost savings, a 100-foot span of uninsulated steam pipe can result in an additional energy cost of up to $31,000 per year, while insulating that same 100-foot of pipe would only cost about $20 per foot or $2,000. So we, in this case, we could save, $30,000 a year with a one-time cost of $2,000. So in most, if not all cases, the cost to insulate equipment is much less than the losses incurred from leaving the equipment uninsulated. So in this session, we discussed several P2 best practices that can be implemented in industries within the automotive manufacturing and maintenance sector. Some are applicable outside of that sector as well. These best practices can help you save money, improve worker safety, and protect the environment, ultimately contributing to a more profitable and sustainable business. I hope that you'll take something away from this webinar that will help toward our pollution prevention objectives. So in the future, for more information on any of these best practices, including technical assistance, please reach out to myself or Dr. Ashish Nimbarte. And also feel free to reach out to us for any other information or assistance related to pollution prevention as it applies to the NEA or other industries, and we'll do our best to help you out.